The overall goal of a Griggs-type experiment is to explore the deformation processes of rocks at high pressure and temperature, typically higher than 1 gigapascal and 300 degrees Celsius.
The advantage of this technique is that deformation can be applied up to pressures of 5 gigapascals. That corresponds to a depth of approximately 150 kilometers in the Earth. This method can help to answer key questions in geology in the fields of structural geology, geodynamics, magmatic studies, and even planetology.
Here we use a new generation Griggs-Type Apparatus, which complies with European standards for safety of high-pressure experiments. Based on the piston cylinder technology, it consists of a metallic frame and 2 hydraulic rams connected to actuators and pistons that first pressurize the sample assembly within a pressure vessel and then advance the central piston to deform a sample. In the present video, we show how to perform a Griggs-type experiment using the conventional solid salt sample assembly.
To prepare the sample assembly, first, grind at least 60 grams of sodium chloride powder of 99.9% purity in a ceramic mortar. Then, cold press the salt pieces. To produce the lower outer salt piece, place 17.5 grams of ground sodium chloride powder into a beaker. Add approximately 0.1 milliliter of distilled water and make sure that salt and water are well mixed. Fill the wet salt powder into the borehole of the salt pressing tool and put its piston components on top of the salt powder. Press the powder at 14 tons for 30 seconds and then unload the salt piece. Take out the lower vessel component and move the 2 basal metal pieces apart.